Hello, Space Lab. I'm Lawrence Krauss, director of the Origins Project at Arizona State University, a theoretical physicist, and also the author of A Universe from Nothing. And I'm here today to answer the following question. Why is there something rather than nothing? Well, the question, why is there something rather than nothing, has been around as long as people have been asking questions, and it's gotten a lot of different answers. First, as a scientist, I should say that really why isn't a good question. When we say why, we really mean how. Because why implies that there's some purpose, and there may be no purpose to the universe. Indeed, as far as we can tell from all the evidence, there's no evidence of purpose. So when you say, why does something happen, you really mean, how does it happen? So the question is, how does something come from nothing? It seems to violate the laws of physics. But in fact, the answer is quite interesting, because it turns out the simplest answer may be that nothing is unstable. It will always produce something. Indeed, once you combine quantum mechanics and relativity, empty space, which apparently, of course, is nothing, is not so simple. It's actually a boiling, bubbling brew of virtual particles popping in and out of existence in a timescale so short you can't see them. And in fact, if you wait long enough and allow gravity to operate, empty space will eventually start producing particles. And in fact, therefore, the answer to the question, why is there something rather than nothing, or how is there something rather than nothing, is nothing is unstable. You're guaranteed, if you wait long enough, to have something. And if you want to ask the question, you'll always be in the places with something. So actually, empty space can produce enough particles to account for all 100 billion galaxies in all, and 100 billion stars in each galaxy. Now, you might say, well, empty space isn't nothing. But if quantum mechanics actually applies to gravity, then space and time themselves become quantum mechanical variables, and whole universes can pop into existence. Spaces and times and matter and energy can pop into existence without violating any laws of physics. In fact, the total energy of our universe may be zero. In fact, when we look out, it looks like it is zero. And that gives us good evidence that perhaps it popped into existence from nothing, because no energy to begin with, and zero total energy in the end, because the positive energy associated with the masses of elementary particles is countered by the negative energy of gravity. Now, the question is, of course, what happened before our universe came into existence? Was there anything at all? And the answer is, we don't know. A simple answer is that the question about what happened before may not be a good question, because since space and time are tied to the matter, when space and time pop into existence, time itself pops into existence, and therefore there may have been no before. The question may simply not be a good question. So there may have been no sense in which you can even ask what happened before our universe began. Alternatively, current ideas from physics suggest that perhaps our universe may be one of potentially an infinite number of universes which are popping into existence at various times. There may be universes being created right now and other universes ending. And if that's the case, then it's possible that the characteristics of our universe are precisely those that allowed us to evolve. So when we ask, why does the universe have the properties it does, the answer is simply, well, if it didn't, we wouldn't be here to answer the question or ask the question. Now, I should say, finally, the question itself is really rather arrogant, because it assumes the universe will always have something in it. But in fact, in the far future, as far as we can tell, all the galaxies we can now see are moving away from us faster and faster and faster. And that means eventually the entire universe that we can now see will disappear when those galaxies are moving away from us faster than light, which is allowed in general relativity. So in the far future, there may just be one galaxy in which we live, and then the stars will burn out and the universe become cold, dark, and empty. And then the simple answer to the question, why is there something rather than nothing, is just wait, there won't be for long.